Okay, so let's show an example of a one single zero system, and we want to check the performance of the system. That is, looking at the frequency response by using MATLAB. Okay, so this is the code of MATLAB, MATLAB code to evaluate the system's frequency response. So let's go through it. Okay, so first we give sampling frequency to the whole system, and fs is how fast you sample the system, your signal. So the highest frequency you can present in this program is 1000, half, right? Half of fs. Okay, now we talk about this 1 0 system. So as we mentioned, 1 0 system, there's no a coefficients, right? So a0 is 1 and no other a's, and b0 is 1, and b1, this is b1, right? So r times exponential j times theta. R is the magnitude of this 0, and theta is the phase of this 0. So let's show Z-plan show poles and zeros of the system, and frequency Z show frequency response of the system. So let's run it. So we run this section. Okay, we're going to show those two things, right? So we have two figures. The first figure is poles zeros. I have 1 0, right, at pi over 4, and the magnitude is 0.9, so pretty close to unit circle. And let's look at the frequency response over here. So we have a none, right? Or we have a value because there's 0. So at this point, the frequency response is pretty low. So we have a value in frequency response, and the position is 250 Hertz, right? Pi over 4, and the magnitude around 20, right? Pretty close to unit circle. Now we want to change one of those two parameters. Now we change r, right? We make it closer to unit circle. So 0.99. Let's see what's going on. Okay, so this time my 0 is very close to unit circle, and the position still, right, pi over 4. This is the frequency response. Now I have much sharper value here, so I have around -40 dB attenuation at this point, but still 250 Hertz. So that means when I change R, I make this value, right, sharper or smoother. Okay, now let's make it a little smoother. So I'm going to make it far away from unit circle. For example, 0.7. Okay, much smoother, right? Much smoother, but position still at 250 Hertz. Okay, this time we keep R the same, and we change theta. So now we change theta to half pi. Okay, as we can see, the value is still same shape, but it's moving to 500 Hertz, so pi over 2. If we change it again, right, 3 pi over 4, we can imagine, right, same shape but change to 750 Hertz. So if we look at those two figures together, okay, the position of this 0, right, the phase of 0 will determine where is this value, right, where you get the very low response, and the position of this 0 determine how sharp or how shallow your value is. When it's closer to unit circle, we have a sharper one. When it's far away from unit circle, we get a smoother one. So this is 1 single 0 system's frequency response.